Today we're going to be talking about our recent heat map that I made. It is a heat map generator written in Rust, and it takes in an array of floating point numbers and turns it into a heat map. The resolution currently is 1024 by 1024, and it's scalable. It's just a texture projected onto a quad. So let me show you that. Currently I'm using super simplex noise. So I go ahead over here to where I create the heat map. And in here, I am first normalizing the data from 0 to 1. And then I generate some meshes, which in this case is just a quad. I was experimenting with having multiple rows and columns of triangles, but it didn't end up needing that because I was just projecting a texture. So go to this, generate the materials. This generates the actual texture. I use 0 to 1, multiply that by 300 to get 0 to 300 in HSV coordinate space. And then I turn that into RGB colors right here. Once I've got that, I turn that into a big array of unsigned bytes. And then once I do that, I turn it into a generic image using this image package. I think it's just called image.rs. And then I use that to convert it to a texture using the rest of my texture pipeline. And then I just send that over to the GPU, and that's tied to the quad via the model. So let me go back to where I had the simplex and change this to Perlin. They're going to look fairly similar, but they're slightly different. And it generates a new one every time it runs. So this is a different heat map than the last Perlin noise one I ran, and it's also a different one than the simplex one. So I can do this as many times as I want, and it'll always be slightly different. I didn't have a good data set to do this for. I was looking for something that was CSV by like XY coordinates, like something like that, but I wasn't able to find anything really good. I did pull a GeoTIFF image, but that's already a texture, so it kind of didn't need to be turned into a heat map. It was already a heat map. It was just in grayscale. So turning it into this didn't seem like it was worth doing. I'm sure there's other data sources that I could pull. The problem is the current way that I'm doing this, every data point needs to be the same size. So if it's not an even sampling, it doesn't really work right. So I'd have to figure out a way to make that work, because currently I'm taking every pixel is a sample. So each of these tiny little pixels is its own sample, which makes it hard to use real data because generally the resolution on that is much less than 1024 by 1024. And it's also not totally uniform distribution. So those are some improvements that can be made. Also, having height displacement, I would have to add geometry to make that work. But as of right now, it seems like a good stopping point for this project.